So this is how the Optima setup looks inside Turbo Design 1. So we have the input parameters here, the constraints and the objectives, and the results of the optimization can be seen here. And starting from the input parameters first, we can see the streamwise loading parameters and also the wrap angle at the shroud, because this wrap angle also has an influence on the pressure distribution around the blade. Next comes the constraints, and so we select the throat because this controls the peak efficiency point, and we also limit the diffusion ratio in order to avoid the scenario of flow separation. And with the constraints specified, we actually move back to the input parameters, where we can see that the default ranges are actually plus minus 10% of the baseline value. But there is actually a machine learning based algorithm in TD1 which will give you the optimal input ranges for these different parameters, and this is because we want to explore a large design space, but at the same time we also want to avoid infeasible solutions as much as possible. And the way to calculate these ranges is using this option here. And just like that, in 10 minutes or so, we have the optimized ranges for all the different input parameters, as we can see here. And then the last step is to select the objectives for our optimization, which is the profile loss and secondary flow factor. And we want to minimize these because we want to increase the impeller efficiency and achieve the target stage height. And with that, we can actually start the optimization run using this option here. And so once the optimization run is complete, we can see all the designs on the scatter plot between the two objectives, the profile loss on the x-axis, the secondary flow factor on the y-axis, and then we can choose to see the feasible solutions which respect all of our specified constraints. And then finally we can choose to see the Pareto run of the optimum solutions, and from this we can actually select any design of interest, and then using this option here we can analyze that. And then we can see that the design has appeared on the project manager window next to the baseline case, and we can also see a comparison between the two performance parameters. We can easily do it in the project manager window here. And here we can see that if we first focus on the objectives, then there is a considerable reduction compared to the baseline case, and there is a slight increase in the diffusion ratio compared to baseline, but it's still well within the limits we set under the constraints. There is also a reduction in the minimum pressure, but it's still well above the vapor pressure of water, and so this cavitation should not be an issue in the optimized impeller. The throat has changed slightly, but this again stays well within the limits of the constraints. And finally, there is not much change in the maximum lean angle, and so there should not be any stress concerns with the optimized impeller. Now we can investigate a little deeper into what has caused these improvements, and we can do this by looking at the different plots available in Turbo Design 1, and we can also choose to compare them with the baseline design just like that. So if we first have a look at the streamwise loading, then we can see that the optimizer has made the shroud highly overloaded compared to the baseline, and this is in order to reduce the profile losses. However, it hasn't made the hub as forloaded as the shroud, and this is because it's trying to keep the secondary flow factor in check, because this combination of loading will actually reduce this difference in the relative velocities in this region, and we can see this is much lower compared to the baseline case. And we can see another reason that has caused this reduction in this gap is actually that we can see the optimized impeller now has a backward wrap at the trailing edge compared to the baseline, and this is another reason which has led to this improvement in the secondary flow factor here. And now, since the optimized impeller looks very promising in terms of the performance parameters, we can proceed further with the CFD analysis of the stage with the optimized impeller.